Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 2, unit number 2. The title of unit number 2 is Matrices and Determinant. The topic of this video lecture is concept of a matrix, its definition and notation. So, how we can arrange a data in a matrix form, what is the concept of that, and then we define the proper definition of a matrix, and then notation for the matrices. Let us suppose that a person, let's say Vakar, let's say this is a person and he has 15 notebooks. Let Vakar has 15 notebook. So we may express this number of books is in the square brackets. I am writing the number of books that Vakar has in the square bracket, with the understanding that inside the square brackets 15 is the number of the notebooks that Vakar has. Now let's say he has 6 pens. So this data, which is the number of books that Vakar has and the number of pens, can be written as this whole data can be expressed as it may be written like this, or you may write this in this fashion. So you see that this represent that this is the number of notebooks that Vakar has, and this is the number of the pen that this person has, or this data has can be written as 15:6 in a column form. So these are the number of books and these are the number of pens, with the understanding that the square brackets, the data within the square brackets is actually the number of books and the number of pen. Now let's say we further move and we say that Vakar has, now further we move and we say that Vakar has, let's say Vakar has 15 notebooks and 6 pens. Another person, let's say the friend of Vakar is Wasim, and he has 10 notebooks and 2 pens. And another friend of Vakar and Wasim, let's say Adnan. So Adnan has 13 books and 5 pens. So how we can arrange this data? So let's say if we arrange this data in such a fashion, let's say these are the number of the notebooks and these are the number of the pens that Vakar, Wasim and Adnan has. So this is the arrangement of the data that is actually present here. Now if we write this data in a capital or small brackets, large square brackets or parentheses, without any top heading or left heading, if we ignore the top heading, these are the top heading and the left heading, and write the data in the large square brackets or in the parentheses, write the prior data in a capital or small brackets without any top or left heading. So this data is become like this. So the horizontal arrangement of the numbers is actually, in this case, is these are the number of the notebooks Vakar has and these are the number of the pens. So this horizontal arrangement is the first row. This is the second row, which actually contain the number of the notebooks that Wasim has and the number of the pen, and this is the third row, and this is the first column and this is the second column, or you can write it into the parentheses. So the above data is written in the parenthesis. Now this data is arranged in this fashion. Now if I arrange the data, if I arrange this data in this fashion, if I arrange this data in this fashion, that the top heading is the persons Waqar, Wasim and Adnan, and the left headings are the notebooks and Finn. So this is also this data can be also arranged in this form. So if we write this data in large square brackets or parentheses without the top heading or and left heading, so this can be expressed like this. Now this is the this horizontal arrangement is actually a row, and this is the first row and this is the second row. So the first row actually contains the number of the notebooks that Waqar, Wasim and Adnan has, and the second row actually contains the number of the fin that Waqar, Wasim and Adnan has. So this is the first row, second row, this is the first row, and this is the second row, this is the first column, second column and third column. So you see that you can arrange this data in two different forms, or you can also write instead of square brackets the given data in the parenthesis. So this is the first row, second row, this is the first column, second column, and this is the third column. So this arrangement of data is called set. This is not the formal definition, but you see the how you can arrange the given data. This data, this arrangement or display of the above kind it may be like this or it may be like this. So this is called matrix. This is not the formal definition. The formal definition of a matrix is a matrix is an ordered rectangular a rectangular array of numbers or functions enclosed in large square brackets or parentheses. So the formal definition of a matrix is this is an order. The formal definition is a matrix is a matrix is an ordered rectangular array of numbers or functions enclosed in a large square brackets. We throughout this discussion of this chapter, we will consider the large square brackets instead of the parentheses. But remember, you can also take parentheses, the given data in the parentheses that I already show. So but we can consider the given data in the large square brackets. So this is the formal definition of a matrix. A matrix is an ordered rectangular array of numbers or function. In the textbook there is written that a matrix is an ordered rectangular array of real numbers. So it is not necessary that it will be always real numbers in the matrix. It may be complex number, it may be some functions, but this is the beginning, this is the introduction of the matrices. So that's why throughout this chapter all the elements that a matrix contain will be real numbers. So it is not accurate in a definition that you say a matrix is an ordered rectangular array of real numbers. So it creates confusion that can be the elements of a matrix may be complex or it may be as some variable, so it can. So this is the proper definition, that a matrix is an ordered rectangular array of numbers or function enclosed in a square brackets. So you see the examples. Now these are the examples. If you see to the examples, A is a matrix which contain -250 square root 536. So all the entries, the numbers or the functions are called the elements or the entries of a matrix. So a matrix contain some data. So all the data points are the number which may be numbers. So the numbers are real numbers or complex numbers, and it may be some functions. So all those functions or numbers is called the elements of a matrix, or it called the entries of a matrix. So you see that this matrix has numbers -250 square root 5 3 and 6. So all these are the entries, or you may say these are the elements. These numbers are said to be the elements of this matrix A. And also remember that we denote matrices by capital letters. So for the notation of the matrix, you will use capital letter always. So these are the some examples of matrix. So you see that this matrix A, this matrix is denoted by capital letter A. The second matrix is denoted by capital letter B, and it contain the elements of this matrix are 2 plus iota 3 minus 1 by 2 3.5 -1 2 square root 3 5 divided by 7. So you see that the element of this matrix which is given in the first row and first column, this is 2 plus iota. So the elements of a matrix may be real or complex, and it may be some function. For example, you see to the set number matrix number C, this matrix which is denoted by C. The entries of this matrix are 1 plus x, x cube 3, cos x, sin x plus 2, tangent x, etc. So you see that 1 plus x is actually a polynomial, the x cube is a polynomial, cos x is a trigonometric function, sin x plus 2 trigonometric, this is also a trigonometric functions. So the entries of a matrix may be some functions, it may be some complex numbers, it may be some real numbers. So the proper definition is, this is the rectangular array of elements in which maybe the entries are numbers or function. So the number means real numbers and complex number. So this is the proper definition and the proper explanation of the definition. In the textbooks there is written that the matrix is a rectangular array of real numbers. So we discussed all the matrices in this chapter which contain all the entries or the elements or real numbers, but it is not the proper way to define a matrix that it only contain the real numbers. From that definition we get a sense that matrices only contain elements from the set of real numbers. So it is not necessary that the entries must always be real numbers. It may be complex number, it may be any function, but in this chapter we will discuss all matrices in which the entries or the elements must be real number. So this is the basic, so that's why we will discuss such type of matrices. Okay, so and I also explained this point throughout. We will use the square brackets to denote a matrix, we will not use the parentheses. Okay, now in these three matrices, if you see the this is called -2 and 5. This horizontal arrangement of elements is called row. So there are 3 rows, and this vertical arrangement -2 0 and 3 5 square root 5 6, these are called columns. So in matrix A there are 3 rows and 2 columns. In matrix B there are 3 rows and 3 columns, and in matrix C there are 2 rows and 3 columns. So these are the number of rows and the number of columns. Now we are in position to generalize the number of the elements. In this case, you see that the number of the elements or the entries are finite. There are you see that 1 2 3 4 5 6, there are 6 elements. In this case there are 9 elements. In this case there are 6 elements. So can it possible that a matrix will contain infinite number of elements? So it is possible. So now this area is can be generalized. So now we are in position to generalize the number of rows and the number of columns in a matrix as follow. So you see that now I am generalizing this area. Okay, if I write a matrix of order m by n, you see that this is a matrix of order. This is a matrix. You clearly see that this matrix contain m rows and n columns. Let us consider the number of the rows in a matrix are m. These are the number of rows. M is an unknown, and the number of the columns are n. So this is the way to write that matrix. Now the question arises here that why I am writing with each element of this matrix in a subscript 2 numbers. So for example, you see that this is the element of this matrix A, and this element is written as small a 1 1. So why I am writing the subscript? Why I am writing this subscript? The reason for this subscript is with the help of this subscript we can easily say that this element is lying in which row and in which column. Now you see that this is the first row and this is the first column. So you see that this element of matrix A is lying in first row and first column. So that's why in the subscript we write 1 and 1. This first one, the first subscript is for number is for the row, and the second one is for the column. So this is a very beautiful notation to write the journal's matrices. Because let's say if I consider this element A23, so without going towards the matrix, we can say that this element of a matrix A is lying in the second row and third column, because in the subscript you see that there is 2 3. So 2 is for the row and 3 is for the column. So this notation is make a sense. You cannot say that instead of A11 A12 A13 and so on up to A1 and I can write something else, because that will become so difficult. Let's say if I write A B C D E and then I write x1 x2 x3 x4 x5 and so on. So for example, if someone take a number, let's say x1, so how you can say that this number lies in that row and that column? So that's why this is the beautiful notation, and we always write the journal set in such a form. This matrix contain m rows. This is the row number 1. You see that in the subscript you clearly see that the first subscript is 1 1 1, and from here there must be a 1 4 a 1 5 a 1 6 and so on. So this is the first row. Why I am saying this is first row? Because the first subscript is 1 1. This is the second row. You see that the first subscript of each element is 2. So this is the second row, and then you see that and so on. This is the mth row. This is the m row, because the first subscript of each element in this row is m. So this is the mth row. Now this is the first column. This is the first column, because the second subscript of each element in this column is 1 1 and so on up to 1. Now this is the second column of this matrix, because the second subscript of each element in this matrix is 2. So you see the 2 2 and 2. So this is the second column. This is the third column. The same reason, because the second subscript of each element in this column is 3 3, and this is the nth column because each element has second subscript equal to n. So that's why this is the nth column. So this matrix contain m rows and n columns, m rows and n columns. So you see that the number of the uh, rows and the number of the columns we didn't know. So this representation can be written in this compact form. This is also written in this compact form. How I can write this in this compact form? For example, you see that this is a matrix A which contain m rows and n columns, m rows and n columns. Now the compact form in mathematics, actually the beauty of the mathematics lies in their notations and their compact form. So now you see that we need so much work to write such a big matrix. So instead of this, I can write it, let's say this is a I j, and I runs from 1 to 3 up to m, and j runs from 1 to 3 up to n, because I already explained that this I, the first subscript of the element, is for the rows and the second for the column. So in this case we are discussing that A is a matrix which has m rows and n columns. So that's why I starts from 1 and goes up to m, and that's why the matrix n has A has n columns. So that's why J starts from 1 and goes up to n. Now if you know the different way of writing things, so it will be more interesting, it become more beautiful. If I write like this, can also be written as a aij, and I am writing 1 less than or equal to m. I can write 1 less than or equal to I, less than or equal to m, and 1 less than or equal to j, less than or equal to n. So for this you can write this, and for this you can write this. So this is the different way to write same things in mathematics. Same formulas and same concepts can be mathematically represented in different form. And if you know that notations and that way of writing, so then mathematics becomes so easy. So this, you see that this is the journal matrix which contain m rows and n columns. Now this can be written in this compact form. So you see that how much it is easy instead of writing this. So this is also because I runs from 1 up to m and j runs from 1 up to n. So this contain m rows and n column. Now this is the now if I take example, you see to the example. Okay, what is the before the example, what is the order of a matrix? This is the order of a matrix. A matrix having m rows and n columns are called a matrix of order m cross n. This is not a multiplication. You read it m cross n or simply m by n. This can be read as m cross n or m by n, or simply you can say m by n matrix. This is read as m by n matrix. So the number of the rows and the number of the column is actually represent the order of a matrix. Now in this case you see that this matrix A has 1 row, second row, third row. So this matrix has 3 rows and 4 columns: column number 1, column number 2, column number 3, column number 4. So this matrix has 3 rows and 4 columns. So if someone asks from you that what will be the order of this matrix, so the order of this matrix is 3 by 4. This is not 3 multiplied by 4. This is read as 3 by 4. It means that this matrix contain 3 rows and 4 columns. If someone say that, let's say we have a matrix B, and matrix B has order 7 by 4. So what does it mean? It means that this matrix B contains 7 rows and 4 columns. This is not multiplication of 7 and 4. This can be written as 7 by 4, 7 by 4, which represent the order of a matrix. Mean this matrix B contains 7 rows and 4 columns. So this matrix contains 3 rows and 4 columns. So we can write in the here in the right corner, below right corner, 3 by 4. The order of a matrix A is 3 by 4, or we can say that A is 3 by 4 matrix. Now from this order we can say that how many numbers a matrix will contain, how many elements or the entries a matrix will contain. So for that, remember, just multiply the number of rows with the number of columns. So in this case, when you multiply the number of rows with the number of columns, you will get 12. So 12 will be the number of the entries of this matrix, or the number of the elements of this matrix. Let's you see that 1 2 3 4 5 6 7 8 9 10 11 12. So you see that when you multiply the number of rows with the number of column, so you will get the number of the elements or the number of the entries of that matrix. So remember this point. This is an important point. So you see that okay, now if I this is the point which I am talking about. The number of the elements in an m by n matrix will be equal to m multiplied by n. Now this is the product. So this matrix contains 3 rows and 4 columns. So the number of the elements in this matrix will be 12. 3 multiplied by 4, you will get 12. So that's how you can find out the elements, the number of the elements or the number of the rows of that matrix. Now also note this point. In this chapter we shall follow the notation, namely A is equal to square brackets Aij m cross n. Now instead of writing this, you see that this is also a little this also need a little more time and a little more work to write a matrix in this fashion. Now if you know a matrix has m rows and n column, so the simple way is that matrix will be written as Aij m cross n. So this writing will revise, or this writing is actually for the number of rows and the number of columns. So this matrix has m rows and n columns. So instead of writing this or this, we can simply write A is equal to Aij m by n. So this is the simple way or the compact way of writing a general matrix. So in this chapter, remember, we shall follow the notation, namely this, to indicate that A is a matrix of order m by n, and the other thing, we shall consider only those matrices whose elements are real numbers or function taking real values. So this point also must be kept in mind. Now another point which is important for eta, this point is also not mentioned in the textbook. So please write down in your notebooks this point. We can represent any point of the plane by matrix. It may be row matrix or column matrix. A matrix which contain a single column is called column matrix or column vector, and a matrix which contain single row is called row matrix or row vector. So this is a point of the plane. You all know from the previous uh, chapter that in a plane, let's say this is a rectangular coordinate plane. Let's say this is x-axis, this is y-axis, and let's say this is a point P having x coordinate x and y coordinate y. So what does it mean? It means that this point has x unit distance on y axis and on x axis and y unit distance on y axis. What in other words, we can say that this point is x unit away from y axis and y unit away from the x axis. So this point is actually x unit away from y axis and y unit away from x axis. So this the coordinate of this point is actually show the position. So this point can be written in a matrix form. This point of the plane can be written in a matrix form. So the point pxy, this is an arbitrary point of the plane. It may be in the second quadrant, in third quadrant, in fourth quadrant, or it may be on the x-axis or on the y-axis. So this is an arbitrary point. The point pxy can be written in ordered in matrix form is. So you may write it in the column matrix. This is a column matrix, or you can say it is a column vector because this contains a single column. Or this point of the plane can also be written in the row matrix, or you can also name it row vector. So this is one of the important point which is not mentioned in the book. Now if I consider a rectilinear figure, let's say a quadrilateral, let's say if I consider a quadrilateral in a plane, let's say this is my quadrilateral, and let's say it has the vertices A, B, C and D. So now actually these point A, B, C are the points of the plane. So if these are the points of the plane, so it must have some ordered face to represent their points, to show their position in a plane. So if I let's say you can draw the x-axis and y-axis anywhere. So let's say the coordinate of this is x1 y1, the coordinate of this is x2 y2, the coordinate of C, which is the vertex of this quadrilateral. This is a quadrilateral, four-sided closed figure is a quadrilateral. So this is x3 y3 and this is x4 y4. So these are the points of the plane. So now if these are the points of the plane and actually these points are the vertices of a quadrilateral rectilinear figure, so these points can be also converted into matrix by the above area. So let's say I am writing that let's say this is vertex A. So the coordinates of vertex A is written in the column. Let's say this is point B, the coordinates of that point is written in the column B. And let's say in the second column, in the third column we are writing this ABC is just for your understanding that these A is actually given to the vertex of this quadrilateral. You can also say this is a polygon. So C is x3 y3 and D in the matrix form will be written like this. And let's say we denote it by X. So you see that the coordinates of the geometrical figure, the vertices of a geometrical figure can also be converted, can also be written in the matrix form, or you can write, let's say it is a y, and in a first row you are writing the coordinates of a point A, let's say. In the second row you are writing the coordinates of point B. In the third row you are writing the coordinates of point C, and in the fourth row you are writing the coordinates of point D. Which are the vertices? These ABC are just written for your understanding. These ABC are just written for your understanding. It doesn't mean that this matrix has such type of different notation. No, it is denoted by capital letter Y. This is just for your understanding. So you see that this is actually geometrical figure, rectilinear figure. This is a rectilinear figure which is a quadrilateral, and their vertices are written in the matrix form. Their vertices are written in the matrix form. So remember this point, that this is an important point, that matrices can be used as a representation of vertices of a geometrical figure. Actually you see that this matrix is the you see this matrix is actually the representation of the vertices of this geometrical figure. So this is an important point which is not discussed in the textbook. You must remember this point. So this is also one of the application of the matrices, that matrices can be used as a representation of the vertices of a geometrical figure in a plane. So I explain this in this way. Okay, now there are some examples. You see it from here, and then study by yourself. Consider the following information regarding the number of the men and the women workers in 3 factories, fact 1, 2 and 3. So you may write it in this fashion, or you can change the top heading to the left heading and the left heading to the top heading, but it is given in the question in like this one. The factory 1 contain 30 men workers, and the factory women workers are 25, and similarly 25 men in the factory 2, and 31 women in factory 2, and in factory 3 the number of the men workers are 27, and the number of the women workers are 26. So you see that represent the above information, this information, represent this information in the form of 3 by 2 matrix. 3 by 2 matrix. So it is so easy. Just remove the top heading and the left heading and write this in the large square brackets. So you see that when I convert it into large square brackets, so it becomes 3 by 2 matrix. This is a 3 by 2 matrix. Now the other question is, what does the entry in the third row and second column? So now this is the third row and second column. What does this entry represent? This is the third row and second column. So this is the entry of the third row and second column. Third row and second. You see that first, second, third. So third row, first, second column. So what does it represent? So it represent the entry of the third row, and the second column represent the number of the women workers in a factory 3. 26. You see in the question, these are the number of the women workers in factory 3. So this is a so simple example. If a matrix contain 8 elements, what are the possible orders it can have? If a matrix contain 8 elements, so what will be the order, the possible orders of that matrix? So you know that from the point that the number of the entries or the number of the elements in a matrix is actually determined by multiplying the number of rows with the number of the columns. So if the number of the entries are 8, so convert 8 into the pairs of those natural numbers from the product of which you get 8, so those are 1 8 8 1 2 4 and 4 2. So the possible order of a matrix may be that matrix may be 1 by 8, that matrix may be 8 by 1, that matrix may be 4 by 2, that matrix may be 2 by 4. So if a matrix contain 8 elements, so these are the possible orders. And how you can determine it? Is determined from the fact that the number of the entries or the number of the rows of a given matrix is determined by multiplying their rows and their columns. Thank you.